Project title: Solar PV Fed Multi-Level Inverter with a series compensator for power quality improvement in a grid connected system. Right? So in this project, we are using a multi-level converter, that means inverter, should be connected to the solar to compensate the power quality issues. So in our system, the power quality issues, otherwise we can call as power quality problems, that are sags, swell, harmonics, disturbances, fluctuations. These power quality issues will be reduced with the help of DVR, dynamic voltage restorer, right? So whatever the magnitude should be presented in the system, that magnitude will be compensated with the help of a DVR, dynamic voltage restorer. So this dynamic voltage restorer is connected with the multi-level converter that will be fed with the PV system. So in this diagram, you can observe that. So this is the our equivalent model to connect the DVR system, right? Next. So next in our project, we are connecting the multi-level converter, right? So like this, the isolated DC-DC converter. These converters will be connected as a like voltage source multi-level inverter. After connection, we are applying different condition cases like the sag and swell. In our project, we are applying the sag and swell. So how much of sag and how much of swell we are applying, right? So in this project, we are using the 0.5 per unit. So we are measuring the output values in per unit system, right? So we are applying the 0.5 per unit and 0.7 per unit. Different sags value will be presented. The magnitude of the sag will be 0.7. Here the 0.7 and here the 0.5. So different timings. The x-axis will be time and y-axis will be the voltages. And also we are applying the swell condition. The swell condition will be 1.2 per unit, right? So these three conditions will be represented in our MATLAB. So this is the MATLAB diagram according to our concept. So how to provide a sag and swell conditions means here we are using the three-phase programmable voltage source. So here we are applying the amplitude value with the time values, right? So initially we are applying the 0.7 and 0.5 should be the sag and 1.2 will be the swell. So we are applying the at a time three conditions, two sag conditions, one swell conditions. The magnitude of the sag conditions are the 0.7 and 0.5 and magnitude of the condition is swell 1.2, right? After the completion of the simulation, you can observe like this. You can observe that. So this is the 0.7 magnitude and 0.5 sag. So this is the 1.2, right? Swell condition. So this is the output voltage. Whenever the sags will be presented and swell will be presented in the waveform, by using the multi-level inverter with the help of the dynamic voltage restorer, we can produce a constant voltage magnitude should be provided to the load. That is our aim. For example, I am applying the input side like, so these are the sags and swell condition, and near to the load side, we are measuring the voltage as a constant magnitude. That means even is there any disturbances occur in the input side, with the help of multi-level inverter with the concept of DVR, we can rectify the problem and we are maintaining a constant voltage magnitude to the load, right? So for the single phase conditions like this, these are the single phase magnitude values, right? So this is the way you can implement your project.